All right. Before I get into the lesson questions, anybody? Oh yeah, we could do that too. Yeah. All right, so let's jump into the lesson then. All right. So kind of want to pick up where we left off. Just a little recap. This is where we left off.
Chapter 7.
We're still in chapter 7. So we have a little bit more to talk about with chapter 7. And then the homework for tonight reflects chapter 7 as well. So I'm just picking up where we left off a little bit, right? So this was the last example that we did in class. So table 3, areas of a standard normal distribution is located in the appendix as well as in the end papers of the text, right? Spend a little time studying the table and then answer these questions. So as the z values increase, do the areas of the left, excuse me, do the areas to the left of z increase, right? And then we said yes, it does. Remember, as the z is moving from left to right, the area under the curve is getting larger, so it does increase, right? If a z value is negative, is the area to the left of the z less than 0.5? We said yes, it is, right? Because 0.5 is the dead middle, right? That's half of the graph. So if the z is negative, it's to the left of that, so it must be smaller than half of the graph, right? The area to the left of it, at least. If a z value is positive, right, is the area to the left of the z greater than 0.5? And we say, yes, that is true as well, right? Because half of the graph is at 0. So if the z is positive, it's bigger than 0. It's 1, 2, 3, whatever, right? So that means that that area under the graph is half of the graph plus the extra area that the z is, all right? So that's the last thing we spoke about, all right? I want to talk about a little procedure right now.
So when it's in the middle,
I'll
it's
show you
zero.
after. In the middle is 0.
Like, wait, so the end is B.
Mm-hmm.
And the beginning is negative B, right?
Right,
Negative
exactly.
B, like
Exactly.
that.
Yes, just like that. But what I want to get into that I didn't get into last time, right? What happens when we're on the other side to the right of Z? That's what I want to talk about. You might have seen this in the homework already and you were like confused. The opposite of it, right? That's what I want to talk about, right? There's a technique that we use to answer that, right? So, no, yeah. I'll show you after. Okay, so let's talk a little procedure, right? So how to use a left tail style standard normal distribution table. So for areas to the left of a specified z value, we're going to use the entry directly, right? For areas to the right is the key part, right? Of a specified z value, you look up the table entry for z and you subtract the area from 1, right? So if I ask you, what is the probability of z greater than blah, 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 right? You're going to find it in the table, and then you're going to take whatever answer that is, which is whichever answer it is, yeah, point, let's say 3,000 or whatever, just making something up, right? And you're going to subtract it from 1. So you're going to go 1 minus point, let's say 3,000, for example, and then that'll be your final answer. Is that 1? Mhm. I'll show you after. I got you. Don't worry. I'll show you after.
Oh, that's the negative,
Yeah.
right?
Negative or positive, same thing. If I say, what's the probability of z greater than blah, 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 this is your procedure. You're going to subtract the answer from 1, just always. So greater than, subtract from 1. Note, chapter 7, yeah. Note, another way to find the same areas to use the symmetry of the normal curve and look up the table entry for the negative z, right? This hint is a little bit confusing, right? So basically it's saying if I asked you what's the probability of z greater than 1.23, what they're trying to say is, oh, you could look up negative 1.23, and then that would be the answer to the question. It's a little confusing though, so I don't want to confuse you with that. That right. Yeah.
P is less than negative.
Right. All of those answers in the table are less than, right? Yeah. I'd rather you guys do the complement rule where like if you look up the answer and then if it's greater than you just do one minus the answer you find. I think that's easier. Chapter 5. It's like the first formula in chapter 5 with A complement is one minus the probability of A, something like that. Yeah. It's like the first problem. Huh? No.
But can you do it?
X bar.
To find the answer?
I got you. Yeah, we're gonna go over examples right now. Um, step 3 real quick, right? For areas between two Z values, Z1 and Z2, where Z2 is greater than Z1, subtract the table area for Z1 from the table area for Z2, right? So if I ask you a probability and it's in between two numbers, you're going to look up the probability for both of those numbers, right? The less than for both of those numbers. And you're going to subtract the big number from the little number. That's it.
What if it's
Right?
great?
That's another story. Well, like we so after the final, come back and ask me and I'll tell you. Yeah. It's not on your final, so don't worry about it. But after your final, come ask me and I'll tell you. Right? It is an interesting situation. All right, so area to the left of Z is given as this. You have your normal distribution, Z, and the blue is what I'm trying to find. Right, what? Just copy. Just copy it.
You can give us an example. Anything.
Yeah, I got examples coming. But I want to explain it first, though, before I jump to the example.
This is the first one on chapter 5.
Yeah, that's the complement rule. So this is it right here. So you see for B, area to the right of a given Z value. So this is the probability that Z is greater than some number. All right. So probability of Z greater than, let's say, Z1, right? You take the entire area under the curve, right? Excuse me. The entire area under the curve, and you subtract the less than from it, right? So this would be like the probability of Z. I don't know. How do I even say this now? No, I'm trying to think like less than, I don't know, 4, make it up, minus the probability of Z less than the Z1.
Welcome to.
Right? It's the same A complement rule. It's the exact same thing. Probability of A complement is equal to 1 minus the probability of A. It's the exact same thing, right? Nothing different,
So how do we know that?
right?
What question? It's gonna be a homework question.
Yeah, yeah. They're gonna say, what is the probability of Z greater than whatever number, right? That's when you do this. This is how you find the answer for it. Well, you're gonna find a probability in the table, and whatever answer you find, you subtract it from 1. That's it. So you just go 1 minus whatever.
Can you give us
That's the answer. I got you. I got you. I'm coming with it. I got you. So here's the alternative approach. I don't really like this approach, but I'm gonna tell y'all about it, right? So it's using the symmetry of the normal distribution curve. So if I say, what's the probability of Z1, for example, greater than, no, excuse me, what's the probability of Z greater than Z1, right? So I'm looking for this area to the right here. I'm telling you that if you look up the negative Z value on the other side, the area to the left is equal to that area,
Is that the
right?
thing?
Right,
Wait, I wanna write this.
right.
So you, if,
Mhm.
I just wanted to tell me how I would write it down, cause I wanna write down what you just said.
So if I ask you what's the probability of Z greater than, let's say, Z1, for example, right?
C being greater than C one, like that?
Right, like
Okay.
this, like probability of Z greater than Z1, right? What I'm telling you is if you look on the other chart, right, it's equal. Yeah. If you look on the other chart, it's equal to negative, it's equal to Z, excuse me, less than negative Z1
Why is that?
because the graph is symmetric. What goes on the right-hand side goes on the left-hand side.
So this is equal? No, you're saying
Right.
it's,
The answers will be equal, you know? But I prefer the other method. I prefer to take the whole distribution and subtract the one that I could look up from it whenever it's greater than. But I am allowing you guys to choose whatever you think is best. All right. Exactly. Mhm. Yeah, I got you. I got you. Let's look at this area between two Z values, right? So if I ask you what's the probability of Z1 less than Z less than Z2, right? In between two numbers, right? You take the area of the biggest one to the left minus the area of the little one to the left. And that's how you get the area in between two individual numbers. I got you. I'm coming. This is the pictures that correspond to it, just so you guys know. All right. So figure 715 illustrates the procedure for using table 3, the area of a standard normal distribution to find any specified area under the standard normal distribution. Again, it is useful to sketch the area in question before you use the table. All right. Y'all winning. Mhm. Yeah. There's a lot of people. Okay. Don't worry, they'll all be gone in about an hour. What are we doing? The same thing? Yeah, yeah, we're just building off of it.
what were you saying a little bit up?
Hey, for which one? Hey, Red Lobster. You winning today. Oh, you're winning today. It is? Oh, yeah.
No, that's where she.
The process, right? You know what's funny? Like the one thing I don't like at Red Lobster is the lobster.
Yeah.
And I can't explain it. No, it's real, but it's like, well, no. You know what's fake? They have a soup over there, the lobster bisque. That's fake. Yeah, yeah. It should be called Legostino's soup, right? It's not actual lobster in the yeah, the lobster bisque soup. Yeah. It tastes good. But it's not actual lobster. It's like a yeah. It's a cousin. So it's a cousin of the lobster and the shrimp. But it's in between the size of a lobster and a shrimp. Yeah. 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 So, right. So figure 715 illustrates the procedure of using table 3 areas of a standard normal distribution. To find any specified area under the standard normal distribution, again, it is useful to sketch the area in question before you use the table. All right. So for me, it's up to y'all, right? You guys can use the table if you want, or you could use the calculator. And I'll show you how to do both. Okay. So notice that the Z values shown in the table of the appendix are formatted to the hundredth position. It is convenient to round or format Z values to the hundredth position before using the table. The areas are all given to 4 places after the decimal. So give your answers to 4 places after the decimal. Hmm? Me personally, if you're using the calculator, just give me everything. We ain't gotta like worry about rounding. Just write everything. All right, I got you.
Wait, Professor, but now it's getting a little confusing.
What's up?
Because, all right, how is this one? Two.
C2?
Z2, and not Z1. What made it Z2?
Because I want the area in between two Z's
Z1, okay, is Z1 and Z2.
and then Z2. So
But then, okay, so when it comes to the line, it becomes Z2.
when I need 2 Z's for the area, right? So Z1 is just area to the left or just area to the right. But when you have 2 Z's, you have Z1 and Z2, and in between is the area I'm looking for. Yeah, yeah. Like looking at the picture, this is what I'm talking about. This is 2 Z's, Z1 and Z2.
That one
Yeah.
is Z2, how?
It doesn't matter. Z2 is the bigger number, Z1 is a smaller number. That's it. Yeah.
Specify, like, what is this?
Yeah.
Area to the left?
Yeah. Yeah. It's not gonna give you the area, it's gonna ask you for the area, but it's gonna tell you the numbers to use.
It's gonna tell us which direction to go, which is gonna.
Yeah, flat out, it's gonna tell you the direction. Yeah.
That's a little bit early because
That's fine.
I accidentally locked my daughter up.
That's fine. Why you do that to that baby?
It's an accident, so she looks at the keys.
Got you.
I don't think she deserves another gift.
Oh man.
I don't think she.
How old is she again?
She's gonna be 16.
16, kind of old.
Uh,
I'm not gonna lie, I thought she was like 8 years old. Bro, I had keys when I was 8.
You know what? I think I was keeping up. Mama was crazy.
Yeah.
Give a shit. Get home.
I used to walk home alone and all that, you know. We walked in groups.
Actually.
Right? Yeah. Cause you know what it was? You know, in the Catholic school, right? So you know, we got jumped. So we had to like we got like we uniform people, so you know, we stand out. So
Well, we were nice. Y'all
What?
were the bullies.
Nah,
Shit.
nah, it'd be the reverse. We be trying to get home like, yo, like, yo, they. Yeah, I remember we let out our school got out an hour earlier than like the public school, so we used to run home in that hour like, yo. Yo, it was real. It was real. Yo, it was real. Public school not bad.
Okay, I felt like Catholic school kids were crazier. I felt like we were more like on the normal side and they felt like they had something to prove all the time. What school?
Oh, we was running from.
I went to 58 and I went to 117 and I went to Wilson. Yeah, no problem.
That sound like some high class schools. I don't even know. I don't even know. I don't know about those. Yeah. Oh, nice.
No, yeah, no, it's not the same.
I heard of it though. They still open? Are they still open?
No, actually, no.
Because
Wow.
a lot of the archdiocese schools got closed down. There was a scandal. Oh,
Stuff like that, and they reached a settlement, and because of that settlement, a lot of this Catholic schools, they go bankrupt.
oh, damn. That's sad.
If you need the Catholic schools are yeah, nah, but they don't really have any, like, the Catholic faith and going in it, even so much of going to church. I mean, they take.
That's facts. That's facts.
But it's bad, how they get a spread that out, there's some schools I would never set foot, they uniform is expensive.
True.
But
True, true.
for prep, Charlotte is one uniform, like $100 something, it's just like,
What the hell?
My daughter is too, but
Yeah.
her school is prison.
Prison.
Success. I'm gonna go to success.
Oh, I've heard a lot of horror things about success.
I heard the name, but I don't know about it.
To good school. That's why she needs to be in there. My daughter,
Mhm.
listen. You don't listen. So I like when they do that.
Yeah.
Keep your hips like this.
Yeah, they were strict.
They sit up like this. My baby be doing that when she's home. I'm like,
For real?
They can't even wear that.
Yeah. They're strict.
Like that.
They can't, they next something.
Right?
Like it's something.
Yeah.
Like, now you speak about it real bad, like.
But don't get crazy with my child, that's next. Your strictness is good.
I didn't know that deep about it, I thought it was from, like, the good school, like.
I used to cry with it, but then my baby go home crying, but not anymore.
Wow.
You go to school to learn.
That's true.
As long as they teaching them and they getting out, with knowledge,
Exactly.
Child, because I've had mine go to Catholic school, private school, charter school, and she's excelling in public. I love that. Oh, wow.
But that's why my daughter out of public though, because the learning.
Because those other schools, they care about like the middle of the class, Like a matter of fact,
It is.
Yeah, but they make it harder because New York State is 44 credits to graduate. Now, if you go to a charter school, it's 52 credits. And they're not even giving you college credits. That's what I like about charter schools. You want my kid to work hard for all these credits, but if they wanna go to a college.
nah, but you know what the you know the reason behind that though?
So, yeah, she's in a public school.
No, yeah, no, but charter school don't. That's it. No, but listen though, like this. Here's the reason why. Say you take. Let's talk about math, right? Let's say you took algebra, you took geometry, you took algebra two trig, right? So that's 1 year of math. It's 2 years of math. That's 3 years of math, right? Flip it now. Let's say that your child went in and took AP Calculus 1, right? AP counts as 2 years of high school. So you could dead be done with high school in like 2 years, but they trying to get 4 years of tuition out of you. That's why. That's why. You know. That's the truth. You know. But to tell you what happened though with like the charter schools and all that, like going back to this, right? You see how we have a normal distribution here, right? What they care about is the middle portion of class. So this area in between. They don't care about the extremely gifted students. They're gonna pass regardless of whatever school they in. And they don't care about them F students at the end because they got stuff going on in their life and they was never gonna pass. They care about that middle portion, right? And then that's why like really gifted students suffer because they have to slow down to work with the class. And then that's why struggling students suffer because like they in some way, shape, or form, they have to speed up just to be on point with the class. You know? This is the problem with school right here. Like this normal distribution right here. So you good.
As far as like high school and stuff like that, because they can't.
I heard,
I still.
I think it's like 2027. It's yeah.
I gotta
So
say.
it's fine, no problem. It's fine, no problem.
Yeah, she keeps texting me like.
It's fine. It's fine.
It
You
wasn't
could
on purpose.
you
I'm
could
just
give
so
me
stressed.
the paper next time.
Okay.
Yeah.
Thank you.
All right, so comment. Notice that the Z values shown in the table of the appendix are formatted to the 100th position. It is convenient to round or format Z values to the 100th position before using the table. The areas are all given in to 4 places after the decimal. So give your answers to 4 decimal places. Next comment. The smallest Z value shown in the table is negative 3.49, right? While the largest Z value on the table is positive 3.49. These values, respectively, far from the left and far to the right of the standard normal distribution, with very little area beyond either value. We will follow the common convention of treating any area to the left of a z value smaller than negative 3.49 as zero. Similarly, we will consider any area to the right of a z value greater than 3.49 as zero, right? So we understand that there is some area in these extreme tails. However, these areas are each less than 0.0002. Now, let's get real about this. Some very specialized applications beyond the scope of this book do need to measure areas and corresponding probabilities in these extreme tails. But in most practical applications, we follow the convention of treating the areas in the extreme tails as zero. All right. So what I'm saying is, right, the convention for using table 3 of the appendix, right? Treat any area to the left of the z value smaller than negative 3.49 as zero. Treat any area to the left of the z value greater than 3.49 as 1.00. All right?
Is that for every table?
For our normal distribution table. And then let's pretend for a second, right, that we're on the test and we forget this, right? Where do you think the answer is? Exactly. Right? All right, so let me show you. Yeah, I'm gonna show you right now. Oh, my fault. That's a video of me. My fault. I ain't mean to show y'all that. All right, so right on if we look on the formula sheet, right? I think it's table 3. I don't remember. Is this one? The one that says areas of a standard normal distribution, right? Now, let's pretend that you're on the test, right? You got a big number. It's like, yo, what's the probability of z less than negative 3.7? What we going to do? What we going to do? Right? So let me look around the room real quick. Only 3 of us got glasses, right? Not counting myself, right? So everybody else is good. So for us with glasses, this is what we gonna do. We gonna zoom in, right? We got to zoom in, so we can't see that. So right here at the bottom. Mhm. Exactly. Yeah. But I'm saying though, if I ask you what's the probability of a z value that's smaller than negative 3.49, let's say negative 3.7, for example, right? Right here, for values of z less than negative 3.49, use 0 to approximate the area. So it's just 0. That's what I'm saying, right? And then it would be 0. Yeah. And then it's not for everybody. It's just for us that wear glasses, right? So, we got to zoom it in a little bit. All right, so then here, for Z values greater than 3.49, we use 1 to approximate the area. Right? So as I was saying, the answer to every question on the test is on the formula sheet. All right?
Not the answer per se, it's the tools to hopefully get things.
I mean, the guy over here that never comes to class and gets 100 on all the tests is from the formula sheet. He's just copying. I'll be honest with you. Yeah. Y'all never see him in class, right? He be getting the highest grade, and he don't even do test corrections.
Does he know me, you know?
Do he? I feel like you smarter than him. He just copying. In my opinion, you smarter than him. He just know how to copy from the formula sheet. That's true. That's true. That's true. He did just graduate from Juice Box. That's true. That's true.
Yeah.
You know the little juice box? You remember the juicy juice? Or the Capri Sun and the Kool-Aid? All right, so let's look at this question right here. This is an example right here, right? So forget the instructions, right? Find the area between z equals 1 and z equals 2.70, right? So let me draw this out real quick. Right? Oh, y'all can't. Oh, shoot. Exactly, right? So this is my attempt at drawing this, right? You know that right here in the middle is 0, right? So that means that 1 is going to be somewhere like here, right? Let's say that that's 1. And then 2.70 is going to be somewhere like here. Something like that, right? And then the area that I'm looking for is right here in the middle. That's what I'm looking for. I'm looking for this area right here. Right? So here's what I'm telling y'all to do. I'm gonna do this real small, right? You're gonna take the area, everything. No, excuse me. You're gonna take the area of the 2.70 to the left of it, all of that, and you're gonna subtract it from the area of the 1.0. And then what's left over is that area in between, right? So essentially, I'm asking you, what's the probability of 1 less than z less than 2.70? And then what you're going to do is find the probability of z less than 2.70 minus the probability of z less than 1.00. All right. That being said, how y'all want to do this? Y'all want to do it on the formula sheet or y'all want to use a calculator? Calculator? All right, let's do the formula sheet first and then we'll switch over to calculator. All right. So look, honestly, the formula sheet is the easier way. Calculator is more complicated. Oh yeah, I got you. I got you. If you're using the calculator, I need drawings, right? I got you. I'm gonna do it both ways. I'm gonna show you, right? But for the calculator, I need drawings. For the table, the formula, all I need is just this one line right here. Right? All right. So now let's look it up, right? First, I want to look up 2.70, right?
Together?
Yeah, let's do it together.
So we using
All right.
distribution.
Right.
That's the
But
only
listen
thing.
though, right, just this one for this section, right? But there's two Z tables, right? There's a negative Z table, as you can see right here, and then there's a positive Z table right here.
Right.
right? So I'm looking for 2.70, right? So all my Z's, right, are right here underneath where it says Z, right? They go out to the tens place, right? So I'm looking for 2.7, right? At the top of the page, these these are where I find my 100th place, right? The the number in the 100th place of 2.70 is the zero itself. So it's going to be just this column going down. This first column. Exactly, right?
Change the 2.70 into a 0.9965.
0.9965. That's it. So this is 0.9965. Then I'm going to subtract it from. Mhm. Well, no, now for the other side, I have to look up 1.0, right? So this would be the 2.70 right here.
Okay.
Yeah.
That.
Yeah.
Either.
Less than 2.70. So now I'm going to look for Z less than 1.0. Mhm. Yeah.
Negative, negative, so that negative, so I mean, less than, that's what, Z2,
Say it again.
Z2.
The negative is no, it's no negative here, it's just positive. Oh, which one is Z1 and Z2 you're asking? Z2 would be the 2.70 and Z1 would be the 1.0. Z2 is the bigger one, Z1 is the smaller one. No, no, we have to look it up first. Right. Mhm.
So we're gonna do the same.
Right. And we're looking for 1.0.
But it's a positive, so we gotta.
Yeah. Hmm.
So staying in that top, that little low.
Right. So what's the answer?
0.41.
That's what I'm talking about. 0.8413.
Okay, and then we could do that on the calculator,
Mm-hmm. So 0.8413. After that, just little subtraction, boom, 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 and that's it.
So when they negatives, right, let's say it's negative 2.7, we gotta go to the negative, right?
Exactly.
Say that, you could just go over to the next call.
And that's it.
Will there be different numbers, like 3.7?
But I was just making that one up. But the numbers would be from anywhere from like decimal or whatever, all the way to
7, right? So it could be like 2.0, 2.1,
exactly.
4.4,
Exactly.
and then we have the whatever. And then if it's like, how do we know which place for it to be in?
Say it again.
How do we know when we have to go to 0.00 or 0.01?
You can always go to 0.000 to do this.
If it's at 2.700,
Mm-hmm.
we'll have to go to the 0.01.
2.7 and then a zero. There's a column for the Z values, and then the 100 places at the top. You match them, then that's it. Hmm? A.
Is this time?
Yeah, all of us. Okay, so.
Yeah.
Oh,
Yeah, I get it done.
oh, you.
Yeah.
Yeah.
Oh, okay, I'm sorry. I'm just making noise. So you sure? Sure?
I know, when I saw you, yes,
Yeah. Mama, that's the one that.
So this, yeah, whenever. Yeah.
But you can't say whenever because, you know, this counts towards my grade.
Yeah.
Say I'm ready to you in January.
True, true. Before the finals. Yeah.
Can you give us a different example? Like, so what is the next?
I got you.
You like, it's
Um,
like it's gonna be cold.
this is a good question.
That's gonna be.
It's not next week. Maybe the week after. No, that'll be the third test. And then there's a fourth test before the final. Yeah.
So long as it's president, don't say Christmas.
No.
It's
No,
the
open.
and,
It is
the 21st.
22nd.
Okay.
But we don't have class that day, so our final might be
Sure.
We don't. have
I'm
13 maybe.
That's the last day. December
That
13th.
that might maybe I might have it wrong.
Oh, I don't think class ends on 20 something. December.
The 22nd. Yeah, the 22nd is the last day.
Wait, I think.
Yeah.
Yeah.
But I wanna
Monday,
no, but that Thursday the week before, that should be our final day.
the 18th,
That day. Yeah.
but we taking the final here.
Mhm.
No, here.
Yeah.
And then you guys have extended time, so it's longer than the regular class. Like y'all might have like 2 hours or something, 3 hours for that.
Yeah.
For the test.
Yeah. Yeah.
But that's.
I think it's the only class I'm taking a final in, like.
It's gonna be here though,
Okay,
right?
this is really my only class in person, the rest is online.
Got you.
Mhm.
So,
And next semester I'm taking
Huh?
all online class, yeah,
Test two?
not coming in.
take that.
I see you at the beginning.
Well, it's gonna be real cold.
Good morning. No, I see you. If you like a good go.
Yeah.
Take this?
I mean, I don't mind coming in,
Yeah.
I'm coming in.
Test two? I didn't give it back yet.
Oh.
Yeah. My fault. My fault.
Definitely she
Yeah.
was talking.
No, that's it. All right, I'm gonna stop the recording. Let y'all know.